right. So, in one of our last poll in this channel, I have asked like whether the user wants a video on this LangChain expression language. So I saw like a lot of users of this channel has voted that uh, they need a video on this LangChain expression language. So I tried to make one so where we will go through this each of the this notebook, and we will try to go through each of these concepts which I am showing as here as the topics of this video, and we will try to break it down, try to understand what goes in the behind the scene of when you are running any codes using LCEL, and we will try to understand how that is working, right? So without further delay, let's get started. So yeah, these are some of the topics. So we will start with how the old code used to work using LangChain and how we can simplify that using LCEL. Then we will go through a few of the runnables, which are like RunnableParallel, RunnablePassthrough, RunnableLambda, and also like how you can use the assign keyword using this runnables, right? So then we will talk about what are the facilities that you get when you're using LCEL in terms of performance benefit, and also how you can make your inference speed much more faster using few of the techniques like async invoke, where we use the concept of a invoke. So we'll talk that in very much in detail in this video, and also the batch support and the async batch support, right? And then we will also talk about how we can combine the item getter with LCEL, and how also we can like bind tools with LCEL very easily. And in the end, we will also talk about the stream support that comes along with this LCEL, right? So after that, like let's discuss about the old syntax that we used to use without the LCEL. Like we have a template where I'm asking a question that I am learning about a skill. So the skill is like an input variable here. Then I'm asking like, can you suggest me top 5 things to learn, right? So with this input variable, I am like kind of making this prompt a dynamic prompt where I can like pass different types of skill, and we can get back the answer from the LLM, right? And then we are kind of importing this prompt template and also this LLM chain. So after that, we are just formatting the prompt where we are passing on the template and also mentioning what the input variables that are present in that template, right? And once that is done, then we create a chain out of it. So where we need to pass the prompt and also the LLM, which will create the LLM chain. Then we used to call this LLM chain dot run, where I am passing the skill, and we used to get the output. This was like the previous way to do without LCL. Now, what does this LCL does is that it makes this whole process much more simpler, right? So here we can see like at first I am formatting the prompt, which is same as the previous way, but now we can see like we are using this pipe operator to kind of create a chain out of the prompt and the LLM. So we are kind of using prompt and chain to create prompt and LLM to create a chain. And then we are like passing this input that the input variable is big data, right? Now I am asking about a question about a different skill, which is big data. And then we are using that chain, which we created here. So that then we are calling this invoke method, right? So, and then we are getting this output, right? So what this operator does is whatever this individual elements are like prompt and LLM. So this prompt produces output, which gets passed to the LLM. Then LLM kind of produce the final output, right? So this is like in each of these components, which are like prompt and LLM, has this individual invoke method. Otherwise, this uh, pipe operator will not work, right? So we will see what this invoke method is, and also like how if you are creating a custom function, and then how you can convert it in such a way that the custom function will also have an invoke method, so that you can create a chain out of using that custom function, right? So then what we are doing is we are simply now adding a parser to it. So it is as simple as like, again, use a pipe operator, then add the parser, right? So here I am using a string output parser, and we are getting the output as string, right? So this is what this pipe operator is, which is newly introduced in this LCEL, which you can just think that it takes the previous output, then it passes as an input to the next step, and it goes on till the number of pipe operator that has been used while creating the chain, right? So now, as I mentioned, like each of these things should have an invoke method. So this prompt should have an invoke method. So you can see, like if I just do like prompt.invoke and pass the input variable, then we are getting this full prompt, right? Where the input variable is replaced with the value that I have passed, right? So similarly, if I capture this into a variable, which is message, using this message, if you just pass that to the LLM, and like LLM.invoke, then I pass this message, which is just the output of the prompt invoke method. So if I just use it, then we will get the final output like this, right? So each of these components which we are using inside this pipe operator while creating the chain should have an invoke method. Otherwise, this chaining of this using a pipe operator will not work, right? So now let's talk about what these runnables are, right? So few of the runnables which are very important, which you should have a clear understanding if you want to work very closely using LCEL. So one of them is like RunnableParallel, RunnablePassthrough, and the RunnableLambda, right? So first we will talk about what this RunnablePassthrough is. So this simple chain which I've created. So here I am just pasted the runnable pass through 3 times. So as the name mentioned, it's just takes the input and pass it through as it is without changing anything, right? So now once I created this chain, if I just do like chain.invoke and give a string like welcome to this YouTube channel, you can see that I am getting the output as it is, which is same as the input, because all these components of my chain and nothing but runnable pass through, which we can create a runnable lambda. So this runnable lambda, which where we can use a custom function. So if I just create just a uppercase of the input, so this is like string upper, which is the name of this function, which is taking an input, and I'm just returning by converting the lowercase values to the uppercase, right? Now using this runnable lambda, you can like bind this to this chain, and now you can create a chain out of it. So you can see like first I am using a runnable pass through, which will take the input and pass it as it is to this runnable lambda function, which will convert this to the uppercase, right? So once that is done, you can see like now if I call this chain.invoke, it's converting this string to the uppercase, right? Because the first input for this chain will remain as it is, then it will pass it through this runnable lambda, and then it will give the output. Now you can think that why we should use a runnable lambda, why cannot we just pipe this custom function and use it as it is to create the chain, right? So as if you remember, like I mentioned, like each of this component of this chain should have a dot invoke method, otherwise this chaining using the pipe operator will not work, right? So if I just see if my string upper has a dot invoke method or not, I am getting an error if I just call this, right? So the function does not have attribute called invoke, right? Now if I convert this function using this runnable lambda and create a variable out of it, so you can see now I have this dot invoke method, right? So if I just do a dot invoke and pass a string, it should return a value. So this runnable lambda, it just takes a normal Python function, then it kind of converts it to a function which has an implementation of this dot invoke method, right? Talk about what is runnable parallel, right? So this runnable parallel, so you pass a single input or whatever the input that you are passing, it will kind of create separate branches using that same input, and that same input will be passed to different branches, and then it will produce the output, right? So here you can see I'm creating a chain where I am using this runnable parallel, where I am creating two chains. One of them is like or two separate branches, you can say. These are not chains, these are, you can call it as branches. Like one of them is like X and another is like Y, and I'm just using this runnable pass through, so it will take the input and give us back the output as it is, right? So if I just call this chain.invoke with this string, which is YouTube, so you can see like it is creating two branches, and it's passing the input as it is to this two branches, and as we are using the runnable pass through, it is producing the same output, but it has two branches, like one of them is X, another is like Y, right? Now if I just make it bit more interesting with this dictionary. Like the dictionary has like key value pairs. One of them has like key as YouTube, which tells you like what is my YouTube handle, then the blog, what is the name of my blog. So that I am passing, and then we can see like still it's creating two branches, and it is producing the input as it is for each of these branches, right? So then we can make it more interesting that instead of just getting the value as it is in the output, we want to do some modifications in the input. So what we can do is we are using this runnable parallel, where we are passing the we are creating one branch where it is just the same as the input. Then what we are creating is we are creating another branch which has the value as blog, and it's kind of using a lambda function. It's extracting the value which is the key of the dictionary is equals to blog, right? So if I now call this chain dot invoke using this same string, we can see the x value is as it is, which is same as the input. Then it's also creating another separate branch where we have where the name is like name of that branch is blog, and the value is the Denkin, right? Which is being extracted using this part of the input. And we can see like this is where the extraction logic is written. So it's just a lambda function, which is kind of going into the dictionary, picking up a certain key, and then it's producing the output, right? So if I just run this, but it works only when this key is present in the input. So if I just change this key, if I make it like blog one, then it will throw an error, right? So because it is not finding the blog key in the input data, so that's why it's creating a error, right? So what we can do is we can now use a separate function, a Python function, which will handle this whenever the key is not present in the input. So what I am doing is I am creating a fetch website function which takes input as dictionary, then it's doing a dot get. So if the this key is present, then it will return that value, else it will return the value as not found, right? So if whenever the key is not present, so it will kind of return the value as not found instead of producing an error, right? So now you can see I'm creating a chain. I'm using this runnable parallel where I am passing this I am creating separate branches. Like one of them is like website, which will do at first it will do a runnable pass through, which will take the input, pass it as it is to this runnable lambda, where we are using this fetch of website custom function. And then we also have this blog where it's just fetching the using a lambda function. It's picking up the key which is related to blog, and it's fetching the corresponding value, right? So you can see like if I just now do a chain dot invoke, it will produce this output. Because this doesn't have the key of website, so it will not throw an error, but it will like produce this not found as the output, right? And blog will be blog value will be printed as it is, right? So I hope you are getting the concept why we should use uh, a custom function like this, and why we should use a runnable lambda, which will convert a custom Python function. And it should have now, once you use this runnable lambda, it should have an implementation of dot invoke method. Now, if I call this using all the keys that it requires, now it will produce the correct value, like the website is this and the blog value is this. What does this assign function works, right? So this assign function kind of enables you to add extra key which you can use in your LLM architecture, right? So think about a use case like where you have different components in your LLM product, and whenever you are making a LLM call, you want to return the value as one of the key as value as like from where that LLM call is getting returned, right? So if you have certain components like a summarizer in your product, right, then you want to like return the value like the sender is summarizer, right? So you can add a custom key whenever you are calling LLM, and then you are getting back the output using that extra key, so which will enable you to track from where the output is getting generated, right? So here I am just creating an extra function. I'm just naming this custom function as extra function and just returning a value as happy learning. Then I'm creating a runnable parallel where I am creating one of the branch as just a runnable pass through, which will produce the output as same as the input. Then I'm doing this dot assign and creating this new key, which is the name of that key is extra. And then I am calling this extra custom function using the runnable lambda, right? So which will give us back the output with added key, and that output key will have the value as like happy learning, right? Okay, so what we can do is, as I mentioned, like this will help you to track from, like if you're thinking about creating architecture where you will track whenever the output is coming, it should have an indicator from where you are getting the output. So this will kind of enable you to do that. Whenever you use this dot assign, you can add an extra key and you can add the source using this extra key. Now let's talk about how you can use LCEL in the rack pipeline. So this we have discussed multiple times in my last few videos, but let's now that you have a good understanding of different types of runnables, now let's see how this is being done using for a rack call, right? So this is like the same stuff which I have been using in my past few videos. Like I'm creating a vector DB, then creating a retriever out of it, and then I'm creating a template like answer the questions based on the following context. Then the context and the question is present in the template. Then I am doing a template formatting and then creating a retrieval chain. So in this retrieval chain, what I am doing is at first I am using a runnable parallel, which will create two branches. One of them is like context. So that context will be fetched using the retriever, and the question will be just a runnable pass through, which means like whatever input that you are sending while calling this chain, it will be passed as it is to the this variable, which is question, right? Now your prompt needs two input, which is like context and the question, which will be gathered using this runnable parallel. And then you will like format the prompt. That prompt will be then passed to the LLM, and whatever the output that LLM is generating, then that will goes through output parser, which is a string output parser, and then it will generate output, right? So this is how you can do. So like I'm creating a question like this, then I'm just noting down the time. So let's see how much time it takes. Like if you do like a retrieve chain dot invoke and then pass the question, you can see like it's taking around 2.212 seconds, and this is the result which we are getting whenever we are passing this question to the retriever chain, right? So after that, now let's talk about few of the improvisations that are available using uh, LCEL. So how you can like improve your inference speed when we are building LLM product. So now the LCEL has a lot of support. So one of them is like async support, which uses the Python's async IO library, and it kind of it will do the LLM calls in the asynchronous manner, right? So this is like a basic difference between asynchronous call and the asynchronous call. So in if you have like four tasks, and if you're doing a synchronous call, so the second task will not start until and unless the first task is completed, right? So every task will wait. Asynchronous call, you can see like all of the task is getting started from the beginning itself, and it will not wait for the previous task to complete. So it will be like it will take much lesser time if you are comparing with the synchronous call, right? So this is like a very basic of what this asynchronous calling means in terms of like a basic Python call. Then if so LCEL supports this asynchronous call using this a invoke method, right? So if I just now do a retriever dot chain instead of using invoke, if I use a invoke, it will be much more faster. You can see like the time taken to complete this was like in milliseconds, like 5 milliseconds, I think, like which is much more lesser than the 2.12 seconds that it took previously to generate the output, right? So this is one of the benefits of using LCEL, how you can get, like, you can improve the inference speed using dot a invoke method instead of the invoke method, right? So then also your LCEL supports the batch calling. So it depends on the model, like your open, if you are using OpenAI model or few of the other open source model also kind of supports this batch call. So instead of, like, if you have like two, you're thinking about putting two requests to the LLM, then what you can do is you can create a batch for those two inputs. And once you pass that batch to the LLM, and then it will only do a one call to the LLM instead of doing two calls. If I passing this two inputs to the model, it will do a single call in two questions. So one of them is like, tell me about Japan's industrial growth, and another is like a question related to sports, which I know like these questions can be answered using the RAG. Now, if I just do a retrieval chain dot batch, so you can see like it is taking 8.8 seconds to get these two outputs, but there is a much better way to do it. So what you can do is, instead of calling this batch in the synchronous manner, you can do it in asynchronous manner also. So what you can do is, instead of doing like dot batch, you can now use this retrieve chain dot a batch. You can see like the time taken is much more less, right? So which is like it's taking 2.06 seconds to give you the output. And this is the output which you can see. Here you can see like the output is written in the form of list, where the first is, this is the answer for the first question, and this is the answer for the second question. Okay, now let's talk about the same thing using this item getter. So this item getter is available inside one of the library, which is like operator. So it just kind of returns dictionary's key value. So at first I'm creating a dictionary just to showcase you like how the item getter is generally working. So you will see like a lot of examples which are there in LCL documents is using item getter. So I just wanted to take you through like very basics of item getter and how you can use for the RAG retrieval, which we are doing. So this is like the dictionary that is being created at first. Then I am importing this item getter from the operator. And here, what you can do is you can mention the key that you want to retrieve from that particular dictionary. So what this item getter return is actually a function. So that function will take the dictionary as input, and it will return the corresponding value that is being used while creating this function, right? So you can see like if I create item getter for website, and then if I pass my original dictionary to this item getter, it will return the corresponding value of that particular key which I have used in the item getter, right? So you can use this inside a RAG. So this is like a quite famous examples, like answer the questions using the context and the question, and you should answer the question to a particular language, right? So your template or the prompt should get like this three input variables, like context, question, and also the language, right? So what we can do is, while creating this retriever chain, we can use this runnable parallel. There we can get the context using the item getter. So using the item getter, you will get the questions value, and then that will be passed to the retriever to fetch the context. And then you can get the question using again the item getter, where the key value as question, and also you can get the language value using the item getter, right? Need to be mindful that whenever you are using item getter, your input has to be a dictionary when you are calling that particular chain, right? So you can use this retriever chain dot invoke, where I am passing the question and also the language. See, like, this is the answer which is generated in Spanish, and it's also kind of giving you a certain description of what is being asked and what is being generated, right? Then let's talk about this bind tools, which I also previously talked about in my last few videos, which are related to LangGraph. So this bind tool was actually introduced with this LCEL, whenever the LCEL was integrated to LangChain, right? So as we are uh, doing certain tool calls, so we need to have a LLM which supports the function calling or the tool calling. So that's why I'm using OpenAI here. So I'm creating a model using this chat OpenAI, and then using this multiply function, I am creating a Python function, and then I am using this tool decorator. I am uh, kind of converting this custom Python function to a LangChain tool. Then what I am doing is I am just binding that tool to this model. So using this convert to OpenAI tool, which also comes in the LangChain core package, right? So once that is done, you can like do this dot invoke on this model with tools object, and you can see like you are getting back this response where it's kind of fetching like what are the parameters for those that function call, and it also tells you that it needs a function call, and it should like what are the values that are associated for the function calls, or what are the arguments for that functions are like first number is 35, the second number is 46. So this is actually supported whenever you are using the LCL component of LangChain, right? So then the last thing, which is like quite important whenever you are trying to improve the user experience. So this stream support, which comes by default with LCEL. So here I'm just creating the same template which we have started this video with. So once that template is done, then I am formatting the prompt, and then I'm creating a chain where this prompt and model is kind of piped to create a chain. Now let's run this to see how this streaming is working, right? So instead of using this a invoke or the invoke method, I am using chain.stream, and then I am printing in this manner, right? So let's call this, let's try to run this, and we can see like the output is being generated in a streamed fashion. So this is quite essential if you want to give a good user experience. So because the user generally will see this streaming output instead of waiting for the full response to come, right? So user will have something to read, and they will be happy with this streaming method. And this is just to improve the user experience using this stream method, which comes with along with this LCEL package. Right. So I hope you got a good understanding of what are the things that is available using this LCELs. I hope you got a good grasp now on the LCEL. And thanks for your time. I will see you in the next video.